operations and also helping to communicate where we are and what this can mean for our customers. But I think most of all, we are supporting it for the benefit of all, more circular world and a more carbon neutral world. So today we will talk about our ambitions in these areas. We will talk about the product use phase, about recycling of steel, about the carbon footprint, and then make a summary and some reflections. There will be time to respond to questions from you, so please raise your hand or write them down in the chat. First of all, sustainability is of course something that is a growing concern in the world, and also in a financially turbulent situation, sustainability means also staying power. And we feel at Ovako since 2-3 years ago, being members of Nippon Steel, have also taken steps towards a more long-term stable situation. We are very pleased to be part of the Nippon Steel group, and with that comes a lot of what makes up the staying power. Technical developments, financial strength, and let's say a long-term perspective on business. In addition to that, we have the environmental strength, and that's what we're talking about today. And on the environmental side, Ovako is actually the leading edge, so to say, within the Nippon Steel group. We have a certain profile that we also are looking to develop further across all of the group, and we hope to bring many good examples with us. First of all, when we talk about steel, we are talking about a material that is abundant in the world. It's said that about 1/3 of the weight of this planet is steel, or iron rather. So iron is not a scarce resource by any standards. It's also so that the price of steel is very competitive. We in Sweden, we like to liken it to the price of potatoes. This picture is from Japan, and they liken it to the price of bottled water. So steel is a cost competitive material to use for many societal purposes. And yes, it is being widely used. 90% of the metals in the world are steel products. And the steel development is still going on. So steel is constantly evolving to more and more better products and more advanced applications. So that's important to keep in mind when people talk about carbon dioxide emissions and so on, that steel, we're not going to see a world without steel. Steel is here to stay. The only thing we can do is to make a difference by how we specify and select steel. And that's where our vision at Ovako comes into play. We have a vision that says innovative steel for a better engineered future. With that, we mean that by choosing the right steel performance, you can also build smarter products and create a smarter society. And we have, as you know, with steel, a whole range of product properties that sometimes compete with each other, sometimes complement each other, but it's a balancing act between all these different properties. And the latest property now to take place in this portfolio of properties is sustainability, or let's say carbon footprint. Carbon footprint is now becoming a measurable property, just like all the other properties. And then it's a question of how do you specify and select your steels? What is the right balancing act? And we are at Ovako proud of our position today. We have products that perform particularly well with regards to clean steel properties. So the fatigue strength makes it possible to design climate smart solutions. And secondly, we have the best carbon footprint among all our peers as far as we can judge. And we have gone rather far in this context. We measure everything from cradle to gate, and we can also provide data for all the individual products that we ship. And thirdly, we are handling a circular material, and we ourselves are very circular. We have 97.1% scrap was the latest figure. So we are very largely scrap-based. And of course, our products in turn, when they are being scrapped, can be recycled and made into new steel again. But we don't want to rest on those first three items. We are also trying to develop our position, and we want to show leadership in a number of projects to further our sustainability position. And the journey we're on can be summarized like this. Today, compared to where we were in 2015, we have reduced our CO2 emissions in operations, that's scope 1 and 2, by 54%. And we have an ambition by 2030 to reduce it by 80%. And we have a road forward to achieve that. Today, we have an 80% lower carbon dioxide footprint than the global average. And in this competitive nature that we're seeing now, people are all over the place trying to reduce carbon footprint, which is good. We have the clear ambition that we will stay ahead of the rest and continue to be the leader in our carbon footprint. 97% scrap, that's fine. Maybe we can get a little higher, but the point here is that we want to address the recyclability of steel. How can we improve the way steel is recycled? And of course, the most important thing that we do is the benefit of our products in their actual end usage. And we will continue to collect such case examples and calculate the CO2 savings. So with our sustainability report that was presented last week, we have also set ourselves specific targets. And we have targets in three areas. And the first area is about the CO2 emissions, where we are looking to reduce our carbon footprint, the cradle to gate carbon footprint. And as part of that, of course, reduce also the carbon dioxide in our own operations, where we can go even further. I mean, in the terms of cradle to gate carbon footprint, we depend on sub-suppliers, and we will work hard with the sub-suppliers to make changes. But in our own operations, of course, we decide ourselves completely the way forward, and we will implement some new technologies that I will show you. In the second area, we, as mentioned, will provide more case studies where we show how we can also make a difference in actual end use. And finally, in the area of recyclability, we are going to actively pursue projects to reduce the concern about copper in scrap. And I'll come back to all of these things. Actually, Katarina will talk about the first area and I will talk about the other two areas. First, about how we develop our leading position, we have realized that among our carbon dioxide emissions, the biggest part is heating steel for hot forming. This is something we have in common with the rest of the world, which is that we use fossil fuels for heating steel. The melting of steel is already electric, and so is heat treatment. But the heating, that's where we spend the most of our carbon dioxide emissions comes from that area. And of course, if we can electrify that operation, it would mean a lot. But unfortunately, it's not technically and economically possible to electrify the furnaces for such big volumes of steel. So we need to take a little detour for electrification. And that's what we're doing. We're planning to implement an electrolyzer. So use electricity to split water into hydrogen and oxygen, and then recombine hydrogen and oxygen again in the furnaces. So we have ensured control system, burner technology, so that all is in place technically to achieve this goal. And once we have it up and running, we will also have two energy systems redundant from each other, meaning that we can switch from one to the other within a matter of seconds. that has a number of important implications I will show you. We did our first full-scale test in March last year. It still is the world's only. And we are now at the final stages of completing the project financing to actually build this electrolyzer. What this means is that we have a fast way to reduce our carbon, to bring us on the journey to complete carbon neutrality. And of course, we are also happy to share the learnings, the concept with others in the steel industry. And when we start to calculate, we see that we're talking about hundreds of millions of tons of CO2 that the world could save, provided that they have access to fossil-free electricity. This also supports a fast implementation of fossil-free transport. So we are working with Volvo in that regard. As you can realize, the problem with fuel cell long-haul trucking is the fueling stations and the cost of the fuel. But since we actually are using much more oxygen than we will hydrogen, we can actually provide hydrogen as a second to long-haul trucking. And Volvo and Ovako is teaming up to make this happen. And that means also that we will be very early, probably first in the world, with fossil-free trucks to deliver to our customers in Europe. We then, since we have two redundant energy systems, we can also provide true electricity flexibility. And that means when you put more wind and solar energy on this grid, you also start to create instabilities in the grid. That is manifested in how the frequency, how stable is the frequency. So you need to for the grid operator, they need certain frequency regulation services. And this is what we can do. We can just switch off the electrolyzer and run on propane for the short period of times when it's needed to stabilize the grid. And that means it's easier than to add more and more wind power on the grid. And finally, in the community where we act, we can also be a provider of hydrogen for many other purposes, with the same logic that I mentioned about the trucks, that we are using much more oxygen than hydrogen, and we'll have hydrogen as a second product. So you can realize this is something that is very exciting, and we are getting a lot of publicity around this. And as I mentioned, I think we are at the very final stages of financing. So hopefully we can bring you good news in the next few weeks to come. So when we look at full life cycle perspective of steel, we think that we need to look at it in three different ways. One is the production phase, and with production we mean everything from cradle to gate. One is the use phase, and one is the recycling phase, where we create raw materials for the next loop of the wheel. For the product use phase, we have discovered since long time, and you probably know this, that with clean steel, you're also having fewer defects that cause stress concentrations. As this steel is cyclically loaded, you will create a lot of stress concentration around the little colored marks you see on the top sample, and therefore you can stress it much less than you can a clean steel. This in turn is what we have applied for many world-leading products. One of the world-leading products that we are allowed to talk about, remember this is often a secret, so people are not so happy to talk about how they apply the clean steel. This is a technical invention where we have been able to solve the issues that was related to so-called IPS drive. Volvo Penta IPS with 2 propellers, reversing propellers, and you run it digitally with a joystick, and it created a lot of stresses underwater. And if they would have used normal conventional steel, the powertrain would have been so big that they also generated extra drag underwater. So this new invention, it solves a lot of things for the people driving the boats, but also it increases the range and lowers the emissions. And Volvo themselves, they promote this with a 30% fuel saving, thanks to clean steel. The other example is an indirect contribution, which is the rings in wind power turbines, the large bearing rings. And as you can realize, this is the most exposed component, really. It's a large steel volume, high loads, under tough conditions, both mechanically and weather and so on. So it creates a lot of room for fatigue cracking, and you need to produce the rings very exactly and with very clean steel. And we supply more than 1/3 of the wind turbines in the world with our rings. And that means just for a small portion of our steel production, we have that supply somewhat of a mission critical component. And the wind turbines themselves supply or save 260 million tons of carbon dioxide during their lifetime. So it's just a calculation to show how much steel quality can matter over the lifetime of the end product. So leaving that aside, I just wanted to highlight that because it still remains the most important thing that we do. Let's concentrate on the other aspects of production and raw materials. So on recyclability, we are 97% scrap-based, as mentioned. And steel, of course, is a particularly good material for recycling. It's attracted by magnets, which makes sorting and handling easy. Most other materials are not. It has also a very low environmental impact in the actual recycling process. The remelting takes much less energy than some of the other recycling processes that we have. And of course, with the sheer volume of what is available in the world, there is also a large economical recycling system in place. It's a traded commodity worldwide. So steel is quite well taken care of. Can still be further improved, but it's already an existing good system. And perhaps most important of all, number 4, as we recycle steel, we also refine it. So impurities in scrap can easily be removed. And we are a living example of that. We supply world-leading steel quality from scrap. So looking at the actual refining, this is what it looks like when we compare to other metals. We bring a lot of constituents up in the gas phase and the slag phase, so it can be removed from the steel and used for other purposes. This is not true as easily for other metals. This is a growing concern, for instance, with aluminum. The more it's recycled over longer time, the more it will also contain elements that are detrimental to its performance. And this is simply because iron is not so easily oxidized. Most other elements are more easily oxidized and can be brought out of the melt. The one big problem we have is copper. Copper is, of course, also abundant among the scrap dealers and mixed with steel all too often. So gradually over time, we will see a slowly rising copper content. So this is our commitment, our pledge, that we will make contributions to improve the recyclability. And of course, own scrap sorting, promoting scrap sorting is very important, and how to dismantle products and so on. But we're also looking at how can we develop other methods to avoid some of the issues. And one of the things we do is to look at creating very pure iron content, and we are members actively in a project called Ferrosilva. But of course, with the Swedish SSAB and LKAB also working in this area, I'm sure there will be other raw materials that can be used for dilution. But dilution is only dilution. We also need to come to the root of the problem, because over time there will be more and more scrap to handle in the world. And therefore, we are researching also new methods to actually remove copper during the refining stage. That's something that is still in the early stages and where we are looking for partners and we're looking for financing. And one thing about copper, sometimes we hear that ore-based steels should be better than recycled steel, and particularly in grinding operations. At least in Sweden, this has been a considered opinion. And for that reason, 3 years ago, a big Swedish government finance project was started on the initiative by Volvo and Scania and others. So for 3 years, they studied and found the exact differences between different steel sources, and none of it related back whether it was recycled or ore-based. Both are equally good. So any differences relate to other factors, and that was a big, important finding. And of course, if people have been locked in to buy only ore-based steels, that's no longer true. And that in turn would save millions of tons of carbon dioxide, just that freedom of choice. So that's also a new finding that we presented in our sustainability report. But now I've used my time for talking, Katarina, and I will leave to you.
Just a short, Göran. We received a question. Would you like to take it now or take it afterwards?
I'm happy to take it now. As the world moves more and more towards electrification and fossil-free power generation, mining for raw material needed will change. You see there's a threat or opportunity for steel in terms of it. Okay. So I can say in general, everything that is getting us closer to a circular society and less CO2 emissions is good for Ovako. It creates higher demands on products. It makes us have to try harder in all aspects, and I think that's good. Mining will need to change. We hopefully can generate alloying content as much as ever possible from scrap. Already today, we are quite skilled at sorting scrap. We will continue to develop that skill. And as we mentioned, it's only 3% that is not scrap-based today, and out of that, maybe half is alloying. So I'm not concerned with that. I think it's a very good question, but at least for Ovako's side, this is not a concern. On the contrary, we welcome all of this.
Thank you, Katarina.
Yes, thank you. Let me continue. I will talk about the carbon footprint, the different ways that we calculate, and also on our path forward to even more lower our carbon emission, and also about some specific tools that we have, and I'm quite sure will be of interest for you. As in, we already have a world-leading carbon dioxide emission, and we will continue working towards even tougher targets for having an even more sustainable future. Our CO2 emissions for our carbon footprint is 80% lower than a general average already today. We have lowered our carbon dioxide emissions from operation with 54% since 2015. But we will continue this work so we will towards our really tough targets, and Göran has already shown them to you. But there are many different ways of showing carbon dioxide emissions, and as I'm sure you all know, there's many different ways you can see it. People talk about different scopes, about different upstreams and downstreams, about footprint, about carbon neutrality, all these different definitions. And it's very, very important when comparing carbon dioxide emissions or footprint that you really compare the same thing. So you compare apples and apples and not apples and pears. It's also very important that these calculations are based on the international standards. Otherwise, it's not possible to compare them as well. They should be based on the ISO standards and the greenhouse gas protocol. We mainly use 4 ways to show our carbon dioxide emissions. And maybe you wonder why 4, why not just have 1? But we use them for different things. They have different purposes. When it comes to showing carbon dioxide emissions, people talk about scope 1, 2, and 3. And on this slide, scope 1 is our direct emissions. And on this slide, it's the steel production, rolling, and further processing. Scope 2 is the energy used in our production. So on the slide, the steel production, rolling, and further processing. Scope 3 is upstreams and downstream. And upstreams is the use of resources and other input materials. It's the alloys, the lime, and other materials. It's the transport to our gates. For us, we mainly talk about downstream is waste management, but also the transport from our gates to our customer gates. So if I'll start with the bottom one, and that is the total carbon dioxide emissions from all our operations, scope 1 and 2, and that is according to the Greenhouse Gas Protocol. That value is mainly used internally to follow up our emissions and all the improvements we do to lower the emissions. That value cannot be compared with others because it all depends on the different company setups. In steel production, in steel industry, it's very common to use the CO2 emissions from the steel mills only, the steel production, which is this one, and it's then divided by ton of crude steel, the emissions from the steel production. This is one value that we also have and will show. We do think that the most important one that really shows the true carbon dioxide emissions is the carbon dioxide footprint, cradle to gate, which Göran also talked about. And that we have for a hot roll bar, and that includes the operation and the upstream. And we can even show that for a specific product, which includes everything, the upstream, the operations, the steel grade, and the yield losses. But I will show you more about this. But it's really important to know the different types of CO2 emissions. And why is it important? Yes, it's because if you have the carbon footprint, which includes the scope 1, 2, and 3, you can, as a customer or buyer, make active, informed supply decisions. That if you do the right ones, will mean large potential carbon dioxide savings. And in the graph to the left, you have the carbon footprint, and you can see the result from our 3 mills and the global average. And as we told you, we have an about 80% lower footprint than the global average. To the right, you have the steel mill only divided by ton of crude steel. The global average is about 1,700 kgs, and our mills are substantially lower. With Smedjebacken with, I would say, the word, or at least one of the lowest in the world, with 60 kgs carbon dioxide per ton. And to make it easy and to show our carbon footprint, we present that in the form of environmental product declarations, so-called EPDs. And an environmental product declaration is a fact-based system to describe environmental properties with a life cycle perspective. It's all environmental aspects, so it's the carbon footprint, but it's also water use, acidification, and so on. So you get specific values for each environmental aspect. It's verified by a third-party auditor, so you really know that the data is correct. So the information is verifiable. And it's registered and published within the international EPD system. And it's based on the proper standards and ISO standards. And it's a great tool to make comparison between different products. It's also a great tool to use while making your own carbon footprint. And Ovako has a steel EPD, or have EPDs for all the 3 steel mills. And these are an important building block for steel using industries to compare our product with other products, but also to use while making your own carbon footprint. You have our carbon footprint, which is then the upstream for when making it, and then we can easily get you the carbon dioxide for the transport from our gate to your gate. And all you then need to add is the carbon dioxide emission from your own operation. So it's a very important building block for steel using industries. These can be found on the International EPD Systems homepage, environdec.com, but also on our homepage, ovako.com. To further improve and to get even more details, we now have the carbon footprint for each individual product. And we calculated in, I would say, quite a unique tool that we have and that we call the carbon calculator. It is based on the life cycle analyze and the EPDs that I just showed you. And we add on the specific processing and any internal transport, etc., for that individual product. We also take into consideration the steel grade and all yield losses. So you get all the different alloys and so on. This has been reviewed and approved by RISE, and RISE is a very well-known research institute in Sweden. And all we need from a customer is the particular product, steel grade, and then we can calculate the footprint for that product. And this is an example from that you get you have a specific article and you get the specific value for that article. And as you know, as we told you, we have an already world-leading carbon footprint, but we also have tough targets to have an even lower carbon footprint, and that, as Göran said, we will continue to have a world-leading carbon footprint. So we have a roadmap, and here's a summary of the roadmap. We have a lot of activities in our carbon dioxide plans, and we summarized it in this roadmap. And this is for our carbon footprint, so it's including scope 3. And we already have lowered the footprint with 36% since 2015. And we have our tough targets of lowering to 60% to 2030 and 70% to 2040. We have done what we've done to lower it already by 36%. Is many different activities. For example, choosing non-fossil electricity, furnace conversion to mainly electricity, process and energy efficiency, upgrade and change of techniques, and optimization of furnaces and other equipment. A summary of what are our plans. We have a lot of plans, but we have summarized it in this slide. And for upstreams is alloy source selection and supplier improvements. It's also the transport to our mills, as well as internal transport. And it's also fuel conversion of steel mills. And as Göran told you about the rolling mill furnace conversion to hydrogen. We still have a few heat treatments that has not yet been converted to electricity. And we will also work with efficiency of internal flows, improved yield, increased sorting of scrap, process and energy efficiency, and many others that are to be identified and to be added on this list. So we have a plan, and are very sure that we will reach our targets. When it comes to the full operations, CO2 emissions from our operations, here you can see the total ton from scope 1 and 2. And as we told you, we already lowered the CO2 emissions with 54%. And our target is to lower to 80% to 2030 and 90% to 2040. And I will not go through the activities again because they are basically the same. And so this is our roadmap to reach our targets and continue to have a world-leading carbon dioxide footprint. I've talked a lot about our footprint, scope 1, scope 2, and scope 3, but we also have, when it comes to downstream, which is part of scope 3, it's the transport from us to our customers. We are now implementing a forward-looking approach to minimize CO2 emissions in transportation. And this is a new tool, a new system that is very unique. And from just looking in the rear mirror to see how much CO2 emission did we have while transporting these goods, we now have the possibilities to decide on the best solution by looking ahead. What are the CO2 emissions? What will they be? And we have the most important input is the distance, transport mode, fuel type, and so on, and this carbon dioxide footprint. We can then get the CO2 footprint for different transport options. So we will be offering the opportunity to evaluate transport options fact-based on lead times, cost, and carbon dioxide emissions. We have an example here, transporting our products from Sweden to France with 4 options. And as you can see, the total lead time differs, the freight cost different, and the carbon dioxide footprint differs. And here it's possible to choose which option. Short lead time, a higher carbon footprint, or a shorter lead time. So we can make fact-based active decision on our transport options. It will also give us the exact data on the transports that we do to each customer, which is an important tool for our customers to make their own carbon footprint. Because then we have the whole chain, which then is the upstream for our customer with our carbon footprint. We have the transport from our gate or customer's gate, and then it's just to add on the operations for our customer to get the full carbon footprint. And you can read all about this and much, much more in our annual overview of our sustainability program in our sustainability report. It was published a week ago, and you can find it on our homepage, ovako.com. You can read all about our environment and climate work, but also about the other areas of sustainability, anti-corruption, employees' health and safety, social engagement, and human rights. So please read. And please contact me if you have any questions about our carbon footprint, how we calculate our EPDs, the carbon calculator, and so on. And now I give the word back to Göran.
Thank you, Katarina. I actually want to go back 2 slides. I see somebody commenting that the audio is not coming, but it's only from 1 person. So I hope you can hear me, and if there should be a problem, I guess we'd hear from more people. So maybe Anna, if you can comment back in the chat line to him that it seems to work for the rest of us. Anyways, there will be, thank you, we can hear, yes. And there will be a recording of this, so it should be in good shape to pick it up later. But I think you mentioned something here that is tremendously important, which is informed, fact-based decisions. And you know, this is very similar to what we do when we select our steel based on strength, ductility, machinability. You know, if you can't get the optimum in all aspects at the same time, how do you base your decisions? And this is what's called management. You know, you have to manage multiple dimensions of choice. And in this case, it's the multiple dimensions of lead times, of costs, and of CO2 emissions. And I'm very happy personally that the world as a whole is now starting to see CO2 emissions as a property, as a decision criteria. So it's not something we can close our eyes to anymore. We need to take that into consideration when we make our fact-based decisions. So we will provide all these options, these fact-based details, and then our customers will ultimately take the decisions based on what is right for them. Hopefully what is right for the planet as well. But in summary, I think it's an overriding idea here is that we need to look along the supply chain, and supply chain is perhaps the wrong word. Value chain is better, where we add value constantly until we reach a final end product. From a financial perspective, our industries are often classified in different groups. They talk about processing industries, about engineering industries, and they talk about automotive or assembly industries. But in reality, those are very connected through a vertical flow of products and services. And what that means is that if you are doing product development, you really need to think from the actual end use of the product and then define how your steel should be made. Similarly, quality issues may not manifest themselves until the very end of the supply chain. And so it is with environmental aspects. The carbon footprint is perhaps the largest in the steel making as compared to everything else. So we need to exchange that detailed information along the value chain. And that's how we can make a difference, all of us together. And I see another question here. Did you say that Ovako now can calculate and provide CO2 data for each individual grade of steel and shipment to the customer? And that is correct. We now have the means, well investigated, approved means of putting everything into what we call a carbon footprint calculator. So any product, any grade, we can provide you with the exact number. And in the not so long future, we will put it on all our invoices too, all our offers, invoices, or acknowledgements. So this is the way that we need to go. We need to provide the same level of details of carbon footprint as we do of strength of steel, ductility of steel, and so on. So yes, taking a value chain perspective helps to promote the right decision making. I think that's ultimately what we're saying, and that's how the world will be changed. The world will be changed by many small actions of individual human beings, perhaps, yes, but industrial professional buyers have a lot of power with the money that they spend, and that needs to be a considered decision. And another question on the carbon footprint calculator. It's internally developed, and we are happy to give responses to products and alloys that people buy from us, but we will not send out the complete details of the calculations other than to state that they have been reviewed and approved by the Research Institutes of Sweden, a governmental organization doing a lot of R&D. So we have the stamp of approval. So my and Katarina's final slide, this is what it looks like typically around our steel mills. The way we have built steel mills in Sweden is dependent on forests and on water power. That's the legacy, forests, water power. So they are situated typically in environments like this. And this means that it's also very close to our heart to protect this environment, to really ensure for coming generations that this is what it can look like. But we are not bragging with this. Instead, we are offering you this as your strength, because when you include the upstream emissions into your carbon footprint, you're also responsible for exactly this. So thank you very much, and we'll continue to take questions here. Do you have transport option and comparison available for other regions than Europe? This is under development, so we will certainly do that. We are working together with logistics companies and different databases to ensure we have those sources. So hang on there, it will come. Katarina, I invite you also if you have something more to say.
No, I think you made a good summary. And please contact us afterwards if you have more questions.
I see applause here, somebody, but thank you all. And I think continue with the questions. We'll hang on here for a few more minutes. Yeah. And we are very open to be contacted on these matters. And I can say as a final also comment that it's so thankful, so rewarding to talk about these environmental aspects, because everybody wants to support it. So it's all, you feel always like you're working with friends when you talk about these things. And thank you all and for joining this seminar.